Hey guys, so today let us learn about structure of some covalent bonds, covalent compounds and the characteristics.
A human relationship, business transaction, contract of employment, lease, etc. exists permanently, based on the nature of the relationship developed or the agreement made between two parties. The strength of the bond between the two parties is exposed when it is broken. These days, we talk about the desirability of a win-win situation in any relationship. Mutual sharing and caring is much appreciated in any long-term relationship. Similarly, a chemical bond between two atoms is clearly understood when it is broken. In fact, for a chemical reaction to occur, bond cleavage is inevitable. The old bond is broken and a new bond is formed in a chemical reaction. To form a chemical bond, a pair of electrons is needed. Let us consider the hydrogen molecule. Each hydrogen atom shares its own electron to form a bond.
Valency means the combining capacity of an atom.
Covalency means an equal combining power of atoms. A covalent bond is formed by mutual sharing of electrons. In the case of the chlorine molecule, each chlorine atom has shared one electron to form a chlorine-chlorine covalent bond. Atoms of equal electronegativity values prefer to join to form a covalent bond. As seen in the table shown here, carbon can develop a covalent bond with itself and with other elements such as hydrogen and boron. What is electronegativity? It is electron withdrawing tendency of shared pair of electrons. Let us consider the chlorine molecule. Since both chlorine atoms have equal electronegativity, they share one electron each to form a strong covalent bond. When the covalent bond is cleaved, the shared electrons are withdrawn by the chlorine atoms. So there is neither loss nor gain for either chlorine atom. Hence, they do not form ions, the charged species of atoms. Hence, the covalent compounds are nonpolar. They are soluble in nonpolar solvents. For example, iodine is a nonpolar solid. It is not soluble in water, but soluble in carbon tetrachloride. A few compounds such as alcohols are exceptional. Lower alcohols such as ethanol are soluble in water, the polar solvent. This is due to hydrogen bonding, an electrostatic force of attraction between positive hydrogen and the nearby electronegative oxygen atom of the other molecule. A covalent bond results in neutral compounds with no free electrons. They are poor conductors of electricity. Graphite is used as an electrode in batteries. Though it is a covalent compound, it conducts electricity because a few electrons travel between layers. Covalent compounds have low boiling points and melting points. For example, in case of ammonia, the bond is stronger within its molecule, but the intermolecular force is weak, and hence the melting and boiling point is low. They exist as gases or liquids. Some of them are soft solids. However, a few covalent compounds such as diamond, carborundum and silica are exceptionally hard with high melting points because of their cage-like structures. Diamond cutting tools are used for cutting sheet metals. They form multiple bonds. Example, oxygen.
So here we have some questions to practice. A bond formation.
A covalent bond can be formed between the atoms of the same element. Examples: hydrogen and chlorine. It can also be formed between the atoms of different elements. For example, methane has 4 covalent bonds between carbon and hydrogen atoms. Some compounds have single covalent bonds, as they combine similar and dissimilar atoms. For example, there are 6 CH bonds and 1 CC bond in ethane. A double covalent bond is formed in ethene. It contains 1 carbon-carbon double bond and 4 carbon-hydrogen single bonds. A triple covalent bond is formed between 2 similar atoms or dissimilar atoms. Nitrogen has N triple bond N. Ethyne has C triple bond C. Methyl cyanide has C triple bond N. The tendency of atoms to achieve 8 electrons in their outermost shell is known as the Lewis octet rule. Electron sharing takes place in order to achieve a stable configuration. We can draw molecules as electron dot structures. Electrons in the Lewis structure, electron dot diagram, are paired to show the covalent bond. The bonds are also conveniently indicated by small lines. Dot and cross marks represent the electrons of hydrogen and carbon respectively. To draw an electron dot structure, we should know the number of electrons available in the valency shell. Let us consider methane. There are 4 hydrogen atoms, each having 1 valency electron, and 1 carbon atom having 4 valency electrons. Carbon and 4 hydrogen share a pair of electrons to form 4CH covalent bond. They combine to form a molecule of methane. There are 4 CH covalent bonds indicated by red circles. Or ethane with a carbon-carbon bond in the same way. The molecular formula is C2H6. 2 carbon atoms, each having 4 valency electrons, and 6 hydrogen atoms approach each other. They combine to form an ethane molecule. There are 6 CH covalent bonds and 1 CC covalent bond in ethane. While writing the structural formula, we must ensure the valency of each atom is satisfied with the appropriate number of valency electrons. For the first carbon atom, the valency is satisfied with 4 electrons from 3 CH bonds and 1 CC bond by mutual sharing. Similarly, the second carbon atom is satisfied with 4 electrons from 3 CH bonds and 1 CC bond by mutual sharing. Stability and octet rule. Each bond represents an electron pair. Let's represent bonds by dots and cross marks and count the number of electrons. Let us identify the first carbon, second carbon, and hydrogen atoms by blue, yellow, and red circles. You can find 8 electrons in the blue circle and 8 electrons in the yellow circle. This satisfies the octet rule. However, you will notice there are only 2 electrons in the red circle, representing a hydrogen atom. Hydrogen is stable with 2 electrons. Thus, an overall stability is achieved in ethane. Let us draw the electron dot structure of ethene. Make 2 carbon atoms with cross marks and 4 hydrogen atoms with dots. Combine all the atoms to form ethene with 4 CH single covalent bonds and 1 CC bond, but left with 2 free electrons. They form another CC bond that results in a carbon-carbon double bond. When we look at the electronic configuration, each carbon atom is satisfied with 8 electrons and each hydrogen atom with 2 electrons. Thus, ethene attains a stable electronic configuration.
Can you imagine paper acting as a battery? Do you know stab-proof and bulletproof jackets are made with carbon? Have you ever thought about a transistor being made with carbon? Have you heard of the growing field, molecular electronics? Scientists say the next big thing after the internet is CNT, carbon nanotube. It is a carbon material with a cylindrical nanostructure belonging to the fullerene form of carbon. A fullerene is any molecule containing only carbon atoms in hollow, spherical, tubular, and ellipsoidal forms. There is a very important and complex science of carbon. It is called organic chemistry. There is a challenging technology based around carbon. It is called nanotechnology. Let's study the significant role played by carbon in organic chemistry. There are 4 main sources of organic compounds. They are petroleum, coal, natural gas, and plants and animals. We get organic compounds such as petrol, kerosene, and lubricating oil from petroleum. Coal tar is another source of organic compounds such as benzene, toluene, xylene, naphthalene, etc. Natural gas primarily consists of methane, ethane, propane, and butane, with other fossil fuels. Natural gas is created by methanogenic organisms in marshes, bogs, and landfills. Natural gas is commercially produced from oil fields and natural gas fields. Plants such as sugarcane and beets give abundant sugar. Other substances of major importance that are derived from plants include starch, cellulose, caffeine, and amino acids. Animals feed on plants and other animals to synthesize amino acids, proteins, fats, and carbohydrates. What would happen to organic chemical industries if petroleum was not available? During World War II, Germany was forced to find out when it was cut off from petroleum and natural gas sources. The chemists proved that they could synthesize many organic compounds based on ethine, which in turn can be synthesized from limestone and coal. In 1828, it was believed that organic compounds could not be synthesized in the laboratory. In fact, the chemicals were classified into two major categories, namely organic chemicals, the substances produced by living organisms, and inorganic chemicals, the substances not produced by living organisms. But this was disproved when Friedrich Wöhler, a German chemist, synthesized urea in the laboratory. He was able to synthesize this first man-made urea from the inorganic substance ammonium cyanate. Urea is an organic substance found in the urine of many animals. Wöhler's experiment broke down the barrier between inorganic and organic substances. Modern chemists consider organic compounds to be those containing carbon and one or more other elements, most often hydrogen, oxygen, nitrogen, sulfur, or the halogens, but sometimes others as well.